So in this video tutorial, I'll be going through how to factorise and solve quadratic expressions and equations using completing the square when the coefficient of x squared is not equal to 1. Please feel free, if you find this video useful, to press the thumbs up and subscribe to future videos. So what I'll be going through is 4 types of examples that you are likely to face, each with a little bit of a twist and something different to its previous question. Now before we start, let me just go through the method of what you should be thinking when approaching these questions. So with regards to the first thing you want to do now, obviously with these questions you will notice that we have got more than one x squared. Now it could be negative, which like we have got in example 4, which I'll go through, but that's the notable difference. And what happens is that when we do go around to factorising using completing the square, we'll notice that we will have a number outside of that bracket which we then need to work with. So going through the steps, so the first thing you want to be able to do is to factorise with respect to the coefficient of x squared. So in this case, as we'll go through, in this case it would be 2. In the second one, it would also be 2. In question 3, it would be factorised with respect to 3. And in example 4, it will be in respect to -2. The second step is then using the method of completing the square, factorise the expression in the square brackets. And then the third step is multiply out the factor in step 1 to remove the square brackets. And again, if none of this makes sense, when I go through the examples, I will recall what each of these are. But this is definitely something that is worth mentioning and something that we will kind of be using as we go through these examples. So getting started then, so if we look at question 1, so here we have 2x squared plus 6x minus 10. So looking at step 1, what we want to do is factorise with respect to 2 using square brackets, and the use of square brackets will make sense in a sec. So here we've got x squared plus 3x minus 5. And then for the second step, what we then want to do is want to use the method of completing the square for what is inside our square brackets. So not ignoring the 2. And one of the reasons why we use square brackets is because now I'm going to introduce another set of brackets. So here I've got x plus 3 over 2 squared minus 5 minus what will be 9 over 4. And simplifying out the square brackets, we get x plus 3 over 2 squared minus, and that will be, so 5 is going to be equal to 20 over 4. So we're going to have 29 over 4. And then the final step, which is then multiplying out, so if I just get a different colour pen. So what we're going to do is we're going to multiply these two things by that 2. So what I end up with is, return to that pen, so multiplying out the brackets, we get 2x plus 3 over 2. So note that nothing inside the brackets is being multiplied because we're multiplying the whole entire bracket. And this would be 29 over 2, and there is our factorised expression. So as you can see, going through this, obviously we would have 2 times 29, which would be 58, and so 58 divided by 4 would simplify to give us 29 over 2. So in other words, the 2 cancels. We can simplify the 2 and the 4, in which we get this expression. So moving on to example 2. So just get rid of all of that. So looking at example 2, so the difference in this one is that here our coefficient of x is odd. So again, we're going to go through the steps. So here I've factorise out the 2, so I've got x squared plus 3 over 2. Shouldn't have done that. Let's get rid of that. X plus 5 over 2. So here, I'm just neaten up that 2. So as you can see, I've taken out the 2, divided everything in the question by 2, in which I get this. So now what I'm going to do is use completing the square for that square bracket. So again, not forgetting the 2, So I've got here bracket x plus 3 over 4 squared plus 5 over 2 plus, minus, again a common mistake that you can make, minus, and it's going to be 9 over 16. So, and there is our square bracket. So then simplifying this, we get x plus 3 over 4 squared. Now 5 over 2, what we want to do is we want to write that so that it's got a denominator of 16. So if I multiply both numerator and the denominator by 8, I'm going to get 40. So here I've got 40 minus 9, which is going to give me minus 31 over 16. And then multiplying out the 2, we get a final answer of 2x plus 3 over 4 squared minus 31 over 8, and there is our final answer. Moving on to example 3. So again, you can kind of get the gist of it. Just takes a bit of practice. Obviously, use of knowledge of fractions and working with trying to manipulate fractions, of getting common denominators, really does come in handy when you're doing this, and the more fluent you are, the easier it's definitely going to be. So moving on to example 3. Now this one a little bit more complicated because here we've got 3 as a common factor, so it's a little bit more awkward, but the method is exactly the same. So here we've got x squared plus x minus 5 over 3. And again, one area that many students mess up on these questions or lose marks is by forgetting that we need to divide everything by 3. So in this question, it's quite easy for us to divide everything by 3 in terms of the coefficients of x and x squared. However, because the 5 is not a nice number to be divided by 3, that's where a lot of students tend to go wrong. And I'll try and write in a straight line for this one. So here we've got 3, and then open up our square brackets, we've got x plus a half squared minus 5 over 3 minus a quarter. And then here we've got our common denominator, which is a little bit more complicated. So here we've got 5 over 3, and we write in our equivalent fraction, so times that by 4 we get 20, and we've got a quarter in terms of 12, which is going to be 3 over 12. So here we're going to have 3 close bracket, square bracket rather, minus, and it's going to be 23 over 12, and then expanding it, multiplying out the 3, we get 3x plus a half squared minus 23 over 4, and there is our final answer there. So moving on to our last example, and the key difference with this one is that our coefficient of x squared is negative. So just get rid of that. So with question 4, which I'm just going to start off here, remember to select a pen, in which we've got, now what I need to do, what's best thing for us to do is, the reason why this one looks a little bit odd is because it's written in a different format. So what I'm going to do is I'm going to rearrange this equation so that I've got my going down in degrees of x, or in terms of powers of x. So I've got minus 4x, positive 3. So as you can see, the sign of each of these things in the expression is still the same. My x squared is still negative, my 4x is still negative, and my 3 is still positive. So from this, what we're going to do is we're going to factorise with respect to minus 2. So here, if I open up the square brackets, I'm going to have x squared plus 2x minus 3 over 2. Just double checking to making sure. So if I was to expand this all out, I would eventually end up with this. And now what we're going to do is just go through the exact same notions of open up our bracket. We've got plus 1 squared minus 3 over 2 minus 1. And again, 1 we're going to write as 2 over 2. So here I've got minus 2 bracket x plus 1 squared minus 5 over 2, and then multiplying out the minus 2, I get minus 2x plus 1 squared plus 5. Sorry about the 5 looking a bit dodgy, just doing the maths inside here, just to making sure it's correct. And there we go. So there is our answer for expanding, for factorising, sorry, when we have a negative x squared. So moving on from that, what we're going to look at now is solving complex quadratic equations in the form of using completing the square. So looking at this, the first step is pretty much going to be exactly the same as what we've been doing. So what we want to do is, first things first, always make sure it's equal to 0, which in this case it is. So what I'm going to do is start by taking out the 2. So I've got x squared minus 3x minus a half equals 0. And again, always remembering to write equals 0, because the examiners are now taking away a mark from students who aren't doing this because we are actually solving. And then going through the stages of x minus 3 over 2 squared minus a half minus 9 over 4. Now obviously with practice you'll get to a point where you are getting familiar with this, and you'll skip a few stages. So here we've got a half is the same as 2 over 4. So we've got 2x minus 3 over 2 squared minus 11 over 4 is all equal to 0, and then multiplying out the 2 we get x minus 3 over 2 squared minus 11 over 2 equals 0. So what we've done is we've gone halfway through the question, we've factorised it with regards to using completing the square. So now what we need to do is to solve it. So as we've already got a single x, all I need to do is make x a subject. So the first thing I'm going to do is get rid of the 11 over 2. So we've got x squared equals 11 over 2. Then you need to ask yourself, do we divide by 2 or get rid of the square? So here we're going to divide by 2. So here I've got x minus 3 over 2 squared equals 11 over 4. We then get rid of the square, so I've got x minus 3 over 2 squared equals plus minus 11 over 4. And just one thing to add is that the square root of 11 over 4 can be written as root 11 over 2. So again, whichever you prefer, you can write it in that format. And then, and bear with that because we got rid of the square. And from this, all we need to do is finish up by getting rid of the minus 3 over 2. So what we end up is with x equals 3 over 2 plus minus root 11 over 2. And there you go. And again, or we can write it as x equals 3 over 2 plus minus the square root of 11 over 4, whichever takes your preference. One's with a rationalised denominator, one isn't. So here are some questions for you to have a go at, both with factorising and with solving. So if you'd like to pause the video, and then in a matter of seconds I'll show you what the answers are, which you should have. And here are the answers. Now the answers you may have for question 2 might be slightly different, only because here we've rationalised the denominator, something that you might want to get in practice of doing once you've mastered the art of surds. So again, if you've liked this video, please give it a thumbs up, and I'll give you an update on and subscribe for an update on the next video.